Ladies and gentlemen, welcome to my talk. It's a pleasure to be here today and to speak in this fantastic setting with this audience. So thank you very much, everybody, for coming. I'm going to talk about miniaturization in medical imaging. So a few words about me. My name is Nadia Neumeier. I have a background in health science and technology, and I work for the company Bridge Electronics. So miniaturization is actually a key element of competence at Bridge Electronics. So I'm very excited to share with you today some of our experience. So why miniaturization? Why are manufacturers trying to make devices even smaller and smaller, at least in certain areas? So there are several reasons. You all know about minimal invasiveness, so a concept from surgery which consists of making small incisions and very few stitches. And obviously, miniaturized devices are a key element to reach minimal invasiveness in surgery. It enables target-oriented diagnostics and treatment, therefore increasing patient safety, and also, very often, it reduces intervention costs for the treatment. Another reason, more from the engineering point of view, is that miniaturized components enable more flexibility in designing medical devices. So just by simply leaving more space to integrate other features into your device. And finally, of course, miniaturization can be a way of distinguishing yourself as a manufacturer from a commercial point of view from your competitors. So all very good reasons, I guess most of you would agree with me. But then, what's next? So how can miniaturization be realized? Also, as you know, it is well known that the devil is hidden in the detail. So what does that mean? I mean, there are several challenges associated with miniaturized devices. When you make a device very, very tiny and small, you still have to guarantee robustness and impermeability to liquids, for example. Also, medical devices need to be suitable for repeated reprocessing when for multiple use intended. And also, when talking about camera systems, dynamically controlled light supply is, of course, crucial, and you have to integrate a light source into your camera. These are the technical challenges. On the other hand, you have, even when you have your concept ready, you have a number of challenges associated with industrialization. So we are in medtech here, so obviously we have to be compliant with the regulatory requirements. We have to guarantee in series that high-quality micro components can be sourced to enable you to deliver this device to your clients. And also, it is rather challenging to make the assembly in a medically compliant environment, because we are talking here about micrometers when it gets really small. So these are big challenges, and many hours can be spent on working on these challenges. What we did is we have broken down these challenges into sub-problems, which we addressed with some of our tech bricks. So I'm very excited to present you today here one of the tech bricks that we have developed for miniaturization, which is a very small camera system with an outer diameter of less than 2 millimeters. It contains an integrated light supply at its tip, and it shows high colored and high resolution in color. Also, this camera system is liquid-proof, completely liquid-proof. It can be inserted into the human body. And here on the left-hand side, you can see a small video showing actually me inserting the tip of the device into a glass of water. And I invite you to have a look at the resolution, which is rather high, regardless whether you look at it from small or larger distances, and that you can really see the contour of this small coin inserted into the glass of water. This device or this camera is suitable for machine washing and sterilization, and it also has a defog feature, so it means it avoids condensation of liquid when inserted into the body, into a wet environment. We currently manufacture devices containing this tech brick in rather large quantities of more than 100,000 pieces yearly. So let me show you now some of the examples where this camera system has been implemented, which are actually on the market and market proven and successful in some of the cases for several years. So for example, you have got here an endoscope on the top right, classical endoscope with a flexible tip. Or video laryngoscope is a very interesting application for intubation, as you can see here in the middle. Other applications include cystoscopes or any kinds of endoscope for different kinds of surgery, or also intraoral scanners with remarkably small tip sizes. So what's next? What will the future bring us? We at British Electronic, we are convinced that miniaturization is going to keep playing a key role in technology, and it is going to leverage innovation. And we see a lot of potential in applications like dental endoscopes or cameras to enable real-time visualization of surgery. Also, we see a lot of potential in the growing field of surgical robotics. And of course, we are very excited to learn about your experience about this, if you have some more ideas. So last, a few words about our company, about British Electronics. We realize medical devices. We do this throughout the entire life cycle of the device. So from the concept to series production to even after-sales support, we work with our clients. We are entirely Swiss-based, near Schaffhausen, hence our booth. And we currently have 140 employees with a growing tendency, about a third of which are engineers, so a very strong focus on technology. We work, as I said, with our partners throughout the entire life cycle of the medical device to create innovation. And you're all warmly welcome to visit us at our booth to have a real look at the devices I showed to you a few minutes ago. They're here, and our booth is right next door. And also you can find more information about us on our website, www.brel.ch. Thank you very much, ladies and gentlemen, for your attention.